In lesson 1.7, you can see that we're now solving systems of inequalities. We just left a section on solving equations using three different methods: graphing, substitution, and elimination. Well, today we're going to be graphing a system of inequalities like you see here. And the solution, the overall solution, will be, after we do the shading for these two inequalities, if these two shadings mesh together or come together or share the same area on this coordinate plane, then that represents the overall solution to the system. So it's really building on what we learned or what we reviewed a few days ago when we were just solving one inequality. Now we're solving two on the same coordinate plane, and we're interested to see if their shadings will mesh together or meet in the same area. Alright, so let's just draw these boundary lines first. Let's start with the boundary line y equals 3x minus 5. So y-intercept of negative 5, slope of positive 3, up 3 right 1, up 3 right 1. That's going to be a dotted line because it doesn't say or equal to. So let me fix my line settings, and with your ruler, make sure you draw these straight. We're going to do a dotted line. Oop, I'm going to keep the colors to match the inequality if I can. Alright, so there's the boundary line for this blue inequality. And the way I prefer to do this is I'm going to wait until the end to do the shading, but greater than would indicate the above side of this line when I do the shading. So I can go ahead and be thinking about it, but I'm just going to wait until I get both of these drawn and then just do the shading all at once. You may prefer to go ahead and shade as you go, and that's fine. Just make sure that if you've got a lot of shading going on your graph, that the overall solution of the inequality system it needs to stand out. Okay, so don't make me guess looking at different shadings on your graph paper. Don't make me try to figure out which part of your graph represents the overall solution to the system. Okay, so let's draw the boundary line y equals 4. And hopefully you remember that that's horizontal. It's going to be solid. It crosses the y-axis at 4, and less than indicates below the line. And now I'm going to do the shading. Now that I've got those two boundary lines drawn, I'm going to shade, and we already said that greater than is above the line, so above the blue, and less than is below, so it's going to be below the red. So the area that's both of those, above the blue and below the red, is this area that I'm shading in green. So we can't go beyond the blue dotted, and we can't go above that red solid. So every ordered pair that we wanted to pick in this shaded region will satisfy that system of inequalities, and that's how we show the overall solution. Okay, so that would be that's what you're going to do on 7 through 15 odd. So let's do another example of this real fast. We know to go ahead and solve for y. So solving for y, we get 3y is less than or equal to 2x minus 24. And then dividing by 3, you get y is less than or equal to 2/3 x minus 8. Alright, so let's just go ahead and take care of this boundary line. Negative 8 on the y-axis, y-intercept, positive 2/3 slope, up 2 right 3, up 2 right 3. It's going to be a solid line. Okay. And I'll get a running start, and there's the boundary line for that inequality. And when we do the shading, it says less than, and that will be below the line. Okay, but I'm going to hold off on the shading and just do it all at once. So here's the red boundary line. It has a y-intercept of -1, And it also has a slope of 2/3, so you're probably thinking, we should have parallel lines here, and you're thinking correctly. Lines that have the same slope are parallel. This is also solid. All right, so these lines are never going to cross. They're going to run parallel forever. And now the shading for the red greater than is going to be above the red line. So we had below the blue line, we'll go ahead and shade now. We had below the blue line, that was less than, and we've got above the red line, because it's greater than. Well, obviously, these two shadings are not going to meet together on this graph forever. This red's going to continue on up, blue on forever going the other way. So when this happens, when the shadings never meet, we finalize this by saying that there is no solution. Okay, so sometimes that happens. There is no ordered pair that we could pick anywhere that would satisfy both of these inequalities. Okay, so in problems 19 to 23 odd, you're basically going to be forming a triangle and then shading inside the triangle, and we're going to be dealing with a system of 3 inequalities. So it's pretty much a continuation of what we did before. Maybe just for sake of order, I'll color code these. I'll do this in red, the middle one in blue, and this one on the bottom, I'll do the boundary line in green. Okay, so just running through this, let's do the boundary line x equals 4, and it's going to be a solid. All right, solid red line. Here's where x equals 4. That's the vertical line crossing the x-axis at 4. And once again, I'm going to choose to do all of my shading after I graph all of these boundary lines. Now, some people like to do this before they shade. They just kind of give themselves a little bit of a hint. They're going to draw arrows like this to show that we will eventually be shading to the left of that line because it says less than, and that's the left side of a vertical line. Okay, let's go ahead and take care of the blue boundary. So y-intercept of 12, 2, 4, 6, 8, 10, 12 is right there. Slope of -3, so that's down 3, right 1, down 3, right 1 again. And this is going to be a dotted blue line. Just making sure I line my points up right. You really have to be precise, because part of your instructions here, if you and we'll talk about all of this, we're supposed to find the coordinates of the vertices of the triangle, and that just means what's the ordered pairs of the 3 points that represent the corners of the triangle. And to get those right, you really need to line your points up precisely and draw really good straight lines. Okay, so finally we need to draw this boundary line. This is a horizontal line. I'll do that in green. And it crosses the y-axis at 9. And it's going to be a solid. Change my line color here. Change it back to solid. 2, 4, 6, 8, 9. Horizontal. Okay, missed it just a little bit, but I think you get the picture. So going back to what we said about the arrows, for the blue it says greater than, so I'll be shading this way for the blue, and for the green it's less than, so obviously that's going to be below. So once again, I'm just trying to emphasize that the solution to a system of inequalities is where all of these shadings come together. Alright, so I'm just going to use yellow, and we'll shade inside the triangle. That would indicate all of the ordered pairs inside this shaded region would satisfy all 3 of these inequalities. Okay, now let's take care of this part. Find the coordinates of the vertices. That's just talking about, these are vertices, these corners where two lines cross, forming the corners of our triangle. And we just have to write down the ordered pairs of these vertices. So this one on the bottom is the point 40. Up here, this is the point 49. And then to the left of that, this is the point 19. So that takes care of these instructions. We found the coordinates of the vertices. We did the shading to indicate the inequality, the solution to this system of inequality. So that's our final answer. I picked one like this because you've got one like this, and it's kind of messy because you can see the numbers are kind of big. So here's what I decided to do with this. First of all, I just noticed that none of these, if you did solve these for y, do you notice that none of these y coefficients are negative? So the bottom line is, when I do solve these for y, if I did solve these for y, I wouldn't have to worry about switching the direction of any of these inequalities, which would change the way I do the shading. Alright, so that's number one. I don't have to worry about that happening, so therefore I'm not going to worry about solving these for y, because to me it's going to be a little quicker if I just find intercepts and just plot 2 points instead of trying to find the y-intercept and then count the slope. Alright, so let me show you what I mean. I'll do this first one in red. Alright, and then maybe if I've done a couple, I won't have to do all of them. But if you want to find, for example, the y-intercept when you're looking at this form without having to get it solved for y, anytime you want to find the y-intercept, just let x become 0. And basically you're solving, if this were an equation form, we'll deal with the shading later, but let's just think about intercepts for just a moment. Basically you're solving this. You just let the x term drop out and you solve for y. And you can use your calculator. You're probably going to need it. If you do 74/8, just divide by 8, just put that in your calculator and you get 9.25. Okay, so we're going to have a y-intercept of a little bit more than 9 on this first line. 2, 4, 6, 8, 9, and then just a little bit more. Okay, we can guesstimate it. And now let's do the x-intercept. Well, just this time, if you want to find the x-intercept, replace y with 0. So you're basically going to be solving this equation. Now again, don't worry about the inequality right now, because all we're doing is trying to find points on the x and y axis. This is going to indicate the shading from the original. So all you have to do is solve these little equations, and to me this is an easy way, as easy as you can get in this problem, to get some points. Alright, so put that in your calculator, negative 74/19, and you get negative 3.9. Okay, so to go along with this point up here, 9 1/4, let's go negative 3 and almost to negative 4. Real close. About as close as you can get to negative 4. And then I'm just going to let those 2 points represent all I need for that particular boundary line. Now I do need to change it to dotted, as you can tell. But just take your ruler, it'll be easier for you. It's okay just to use 2 points and line those up as best you can and draw that boundary line. We'll try that again. It's not always easy with just 2 points for me, but for you it should be not too bad. Okay, so we got one boundary line, and now let's just do this one in the middle in blue, and let's just follow that same line of thinking. Here we are. Let's just, for example, we want to find the x-intercept. Where does this line cross the x-axis? Just pretend like this y term's not even there. y is 0, which makes all of this 0. So you're just going to solve 26x equals 119, and therefore x, if you just divide 119 by 26 in your calculator, you get 4.6, about 4.5 on the x. Okay, so we'll put that dot about right there. And then to get the y-intercept, you just let x become 0. Okay, I'm just going to look a little dividing line here and just solve this. And in your calculator, 119 divided by 38 is 3.1. So on the y-axis, just a little bit above 3. And just take your ruler. This is going to be a solid line. And let's do our best to line those points up. Looks pretty good, I guess. Okay, so 2 of our lines are down, and then I'm going to save the time of walking you through that. You've seen this. I'm just going to do this one in green. But going through this same process, I went ahead and figured these out to save a little bit of time. The y-intercept will be negative 3.7. So I'm going to guesstimate that to be about right there. And the x-intercept is going to be kind of big, so if you want to just make some marks instead of changing your units, it's 16.5. 2, 4, 6, 8, 10, 12, 14. I'm going to put 16.5 about right there. And let's draw these, connect these dots. Change my line color, keep these straight. This is also going to be a solid. So let's see if I can connect these. I'm not really close. Okay, I think I got it. I probably just need to make this a little bit longer. See if I can extend this a little bit, because I really need to see where these are going to meet. Okay, so do you see the triangle that's formed here? And basically the way the shading goes, it should be shaded inside the triangle, because we're going to do less than the red, which is below. We're also doing less than the blue, which is below. We're doing greater than this last one that I've done in green, which is above. And so you put all those together and you're shading this triangle. Okay. And then I don't want to take too much time. I've already probably gone a little bit longer than I wanted to go, but your last step is to identify as best you can. If it doesn't show up exact, give me your best guess, and if you're in the neighborhood, I'm going to say you're okay. But tell me the ordered pairs of these. Typically I would make you be exact, but I'm going to save you a little bit of time, and if you'll just get me as close as you can with your best guesstimate, that would be okay. Alright, so don't forget to list the vertices. Those are those 3 points which make the ordered pairs of the corners. Okay, let me give you a tip on this one. You got 2 problems that involve graphing absolute value inequalities. And you may have covered this in Algebra 1, I don't remember, but let me give you a quick tip on how to graph absolute value. First of all, you can always remember this. The graph of absolute value, I always tell my students, if you'll just spell absolute value with a big exaggerated V. Because anytime you're asked to graph an absolute value function, it's always got to produce a V shape. And there's more than one way of coming up with this V, but this is the way that I like, and I'm going to show it to you. And you'll do the same process on numbers 28 and 34. So when you do this problem, you can put a little m above whatever is in front of x. You can put a little b in front of this other number inside the absolute value, and then you can put a little c above this number that's by itself outside. So what I'm doing is I'm going to give you a formula for finding this bottom part, this tip of the v that we call the vertex. Okay, it's kind of like a little shortcut for helping us find exactly where that point is called the vertex, and here it is. Okay, you can find the vertex anytime you want to find the vertex of an absolute value graph. It's found like this: the opposite of b over m, comma c. So this will be the x coordinate and this will be the y. So applying our problem in this situation, remember we labeled 9 as b, we labeled 3 as m, and this other number by itself outside we called c, which is -4, and then simplifying we get the point -3, -4. So that is my vertex of this V shape, and I know it's got to open upward like a regular V because it's positive right here. If there were a negative sign there, then I would have a V that opens downward. Okay, so this is going to be, from this point, I'm going to have a V opening upward. Now how do I get the rest of the V? Well, think about how you count slope. Remember M stands for slope. So what I'm going to do, from this point, I'm going to count a +3 slope. I'm going to go up 3 and right 1. And I'll do that one more time. Up 3, right 1. And you're thinking, well, that's half of the V, but how do I get the other half? Well, go back to your vertex and do the -3 slope. 1, 2, 3, left 1. 1, 2, 3, left 1. Okay, now you can see the V, and now we just need to connect the dots with a solid line. Okay, V's can also be dotted if this is not or equal to. So I'm going to change my line type because this is not really a double arrow, this is just one arrow. And I'll change the line color. I'm actually doing the absolute value in blue, but I won't waste your time and change the color. So here's the V. Okay, and the shading for V's works just like shading for lines. It's just that there's two lines. So greater than for a line would be above the line. Well, for a V, it's above both of these lines, and so what we're talking about really, greater than in this case, will be everything inside the V. And again, I'm just going to wait and do my shading at the end. I'll just stay in blue. Here we're going to do the typical solve for y. 2y is less than or equal to -x plus 14, and now y is less than or equal to -1/2 x plus 7. So we go to a y-intercept of 7, 2, 4, 6, 7. And we count a slope of -1/2. That's down 1, right 2. Up 1, left 2. That's going to be a solid blue regular line. Okay. And this line cuts through my V, as you can tell. And now all that's left to do is the shading. So I'm supposed to shade below this line, but we already said we're shading inside the V. So the result of this is I cannot go over that line, and then I've got to stay within the V. So this represents the solution, everything in the yellow. So I wanted to give you a little heads up because a couple of your problems involve graphing these absolute value functions, and this is to me a quick and easy way to find the vertex and then just count the slope, both positive and negative, from the vertex, and you'll have it. Need to fill that in there too. Okay. All right, so I hope that helps, and if not, you're welcome to send me an email and ask questions, or come and see me in academic support, and I'll see you next time.